Hey guys, Saion Gupta here, founder at 10x Coder Kids and an official Guinness record holder for the youngest computer programmer in the world. And today you're gonna be learning about the structure of a contract in Solidity. So without any delay, let's get started. And before we move on to studying about the structure of a contract, need to know what contracts are. Basically, a basic definition says that contracts are similar to classes that are there in your object-oriented languages. So it's very similar to the classes that you have in your object-oriented languages. Alright? Pretty cool. And in the last video we learned about this first statement of our program, that is the SPDX license identifier. We also learned about the pragma, and now we are gonna start with how the structure of a contract. So if you don't know what these lines means, do check out my previous video. Alright, so first of all, we are gonna look at state variables. So if you must have done any other language, you must be knowing that variables are basically names for values, right? So you can store values in variables that we can use further in your program. And you have local variables and global variables. Global variables are those variables which can be accessed throughout your program. Local variables are those variables which are accessed only in a class, function, etc. Right? So over here, state variables basically mean all the variables which have a state. Like if it's a global variable, is it a local variable, right? So if I define here event, and for example stored data, this will be my state variable, that is a local variable, and it will be only accessible for a contract, global contract. Note that I have named my contract global contract because I will be using this contract for many other examples, right? So here's how you can define state variables, which are basically containers to store values, right? You have many data types which you can choose for your state variable, like uint. So this is an unsigned integer, so you can store number values. Alright, so so this was it for our state variables. Now let's move on to our function. Okay, right, so we are on our functions, and basically to define functions, what you'll say, we're gonna use the function keyword that we have used in many other languages also. Then we're gonna name the function, for example bid, and I can have these functions inside of my contract or outside of my contract. That's my personal choice, right? Next we are gonna give the access modifier, so I'm gonna make this function public. You have four types of functions: public, private, internal, and external. Right now we are gonna use public, which means that this function will be accessible everywhere, right? So wherever we want to call this bid function, we will be able to call, right? Next we are gonna say payable, right? So this is a keyword, and basically what this does, this payable thing actually says that this function will be able to transfer money from one place to another, right? So this is a keyword which says that transfer of money can be taken place, and as you can see here, you must have seen this 98 gas symbol. This is saying that to run this function, to make this transaction, it will take a 98 gas. So what is gas? Gas is basically for every transaction you make in the Ethereum blockchain, you'll have to pay some gas, right? Some fees, that is known as gas, right? So over here, to call this function, we'll have to pay 98 gas, right? So this will be a fee to use this function. We can also define the function outside, so like function, and I'm gonna name it. And what I can do, I can also accept parameters. So I can say I want to accept a number x, right? And I'm gonna say pure. Now pure is a keyword. What do we mean by pure? Pure basically means that we don't want to read or write to the data of our file. We just need to use this function for small computations. We don't need to make any change in the Ethereum blockchain through this function, and we don't need to read anything. We don't want to read any logs or anything. We just have to keep it simple in this function, right? So over here in pure functions, you can't read or write to the Ethereum blockchain, right? And next we have returns. So we can give the type, that what type it returns, and I can say uint, so it returns unsigned integer, and then we are giving the brackets. And basically what we can do, we can return x into 2, right? So we are using the x value that was passed in, and we are just multiplying it by 2 and returning it, and the return value will also be an unsigned integer, right? So I hope I'm clear with this. And next concept is function modifiers, right? So I'm gonna comment out this, I think, right? So I've commented this function, and now over here we have modifiers. Modifiers are very function modifiers. Function modifiers are very simple, similar to normal functions, and you will see how. So we are gonna see the modifier keyword, and we're gonna say only seller, for example, right? Just keep looking, and we're gonna say in this require. After I write the code, I'm gonna explain all of it, right? And here I'm gonna say message dot sender is equals to seller, and also I'm gonna say address. Okay, just follow, right now, just follow with what I'm doing. Address seller, right? So I'm gonna say address seller. Okay, so we're gonna say address public seller, right? And we're gonna say over here, after this we're gonna say only, sorry about that, only seller can call this function. All right, I'm gonna give a semicolon here, and do I have to give this, and what error is it showing? No quick fixes available also. So it's showing me an error. I'm just gonna look into this, and I'm gonna get back to you. So all right, apparently I wasn't giving a comma over here, so that was mandatory. And also this what do we say, underscore and semicolon over here is also mandatory. I'm gonna explain this in a second. I'm gonna use the bid function only with the public access modifier, and we are gonna say it view. Like we had pure, we have view also, and this will only read stuff from our Ethereum blockchain, right? And we're gonna say only seller. So this will use the modifier only seller. You can see the gas has bumped up to 2621, and when I didn't give only seller, it was only 144, right? So pretty good. But over here, now let me explain this example. What we are doing over here, first we are gonna create a variable of type address. So this will be an address of a user, that will be our seller, right? So maybe he's a seller of some product, right? Next we are adding a modifier only seller. Before that, we're gonna see the function. This function over here is saying that use only seller. So what is going to happen? I'm just gonna say more code, right? So what is going to happen here, when I'm saying modifier only seller over here, it basically is saying that it first has to fulfill this, and then only whatever code I write will come here. So what this actually means, when I've given only seller over here, this is first checking that if the sender, basically the person who is trying to invoke our function, is the seller. And if he is the seller, then whatever code I write in this will be executed. But if he is not the seller, we will get a function in our console that is only seller can what I'm saying, can call this function. Only seller can call this function. And what is happening if this statement is true, it will move on. And to execute this code, all the code that we write in this will come over here, right? So it will essentially come over here, right? And it will execute that code. But I can also I could have also done, I could have copied this require statement and I could have pasted here, right? To say and it would work and if I would have removed this, it would have worked the same, right? But if you want the same requirement for 10 functions, for example, if you want the same modifier for 10 functions, if you want to use this piece of code for 10 functions, then you can create a modifier that you can use with all your 10 functions, right? So pretty cool. It basically shortens your code and makes it more readable, right? So next we are gonna be moving on events, right? And I'm gonna basically comment most of our code here, right? So next we are gonna move on to events. So let's start. Okay, so now events. So first I'm gonna similarly write the code. So what I'm gonna say, I'm gonna define our event that is highest bid increased, and I'm gonna say address bidder and unsigned integer amount, right? And what I'm gonna do here, I'm gonna just create this I'm gonna use this function bid, but I'm gonna say public and I'm gonna say payable, and I'm gonna remove this only seller modifier, right? So we are gonna use this function bid and all right, so I forgot the semicolon here. So we're gonna use this function bid, and in this what we're gonna say, we are gonna say emit highest bid increased, and we're gonna say the bidder is the message dot sender, and the amount is message dot value. So what do we mean over here? Basically, what are events? First you will have to understand what are events. So events are basically some places of code. So whenever these events are triggered, you can make changes in your program. So for example, highest bid increased, when the bid is increased, I can make changes in my program. I can perform some specific task whenever I receive that the event has triggered, right? So over here emit is triggering, it's triggering the event highest bid increased. So we are defining the event over here. Highest bid increased event is defined over here, which is getting address bidder and you unsigned integer amount, and with this information you can make some changes in your program. So this is the definition of our highest bid increased event. And to trigger the event, you use the emit statement, emit keyword, right? And then you give the name of your event, and then you're gonna give the values that who basically gave the last bid and what was the value of the last bid. So for example, the highest bid right now is 20, right? And I'm gonna bid like 30. So what will happen, this highest bid increased event will be triggered, right? And it will say that Saion has given the value 30, and with those values this event over here can change some specific parts of the code. I hope I am clear with this, right? All right, so next we are gonna move on to errors, right? So so let's move on to errors now. Okay, so by using errors, you can create your own custom errors, right? So I'm gonna, for simplicity, I'm gonna remove this code, right? I'm also gonna remove this code, right? And we're gonna start fresh. over here what I'm gonna say first these triple slashes. I'll explain in a minute. In a minute. Not enough funds, and then we're gonna say error, not enough funds, and we're gonna say uint requested and uint available, right? So what this is saying, that this error can be triggered, right? So this error can be triggered, that is not even enough funds, right? And it will get the requested amount to transfer from one account from to another, and what is the available amount, right? And basically when this error is triggered, this statement that is written after the triple slashes, not enough funds, will be shown in our console, right? Okay, so next what I'm gonna do, I'm gonna create a mapping, right? So this I'm gonna create a mapping, and over here I'm gonna say address to uint. I'm gonna name this balances. I'm gonna explain balances. I'm gonna explain all this. So first, what this mapping statement is doing, it's saying that whatever addresses you have, associate them with an unsigned integer, right? And this will be a mapping type, right? And all the mappings will be saved in our balances variable, right? And after this, we're gonna create a function transfer. I'm gonna make this public, right? And over here what we are going to do, so whenever someone tries to transfer, we have to do something, right? Okay, okay, so we are gonna say address, and we are gonna say address to and uint amount, that we, so basically saying that to whom do we want to send the money, and what amount do we want to send. And over here in this we have to do something, right? So what we are gonna do, we are gonna first take out the balance of the person who is trying to transfer money. So we are gonna say unsigned integer balance is equals to balances, use the balances mapping, and gonna say message dot sender. So whoever has invoked this, take out his balance, right? So what are these yellow lines? Okay, let's leave these yellow lines. So and once we got the balance, what we're gonna say, if we're gonna check if if the amount we want to send is greater than the balance we actually have. So what we are going to do, we're gonna revert. So this revert statement will invoke the error, not enough funds, right? And we're gonna say what was the requested amount. The requested amount was our amount, and the available one was our balance, and here it will be balance, right? So next if this statement is true, so then it will just invoke the error, right? And this will give us the custom error, not enough funds. But if this is not true, then we actually have to transfer the money. So what we'll do, we'll say balances, and to whoever we had to send, we'll add the amount, and we'll subtract the same amount, that is balances. So we are gonna subtract the same amount, balances, and message.sender from the message.sender, right? And am I forgetting here something? Is it the brackets? Yeah. Oh no, it is not the brackets. Just a second, guys. I'm gonna get back to you soon. I knew I didn't have to give the sorry, I didn't have to grip the brackets, so I'm giving the semicolon here, right? And this is system is going crazy. It will take infinite gas to basically transfer money, right? So this is just not true, right? So basically I forgot the semicolon, and here is your basically transfer of money contract, basic transfer of money contract, right? Now this was our errors. Now we are gonna move on to structures. So structures are basically a data type like thing, right? So it's basically a data type like thing. So where you will have like information for one step specific thing, right? So for example, it's basically a collection of multiple variables. So here in the structure I can have voted. So we are creating a voter structure to keep track of a voter, and we're gonna check. We'll have a boolean value in this if to check if he has voted or not. We'll keep the voter's address, right? And we can add many things like the weight of the voter. So this will be an unsigned integer weight, right? So this will be basically a collection of variables, right? Structures basically is used to store multiple variables with their values in one single variable. So you can use these values, and basically we are understanding over here that voter and what all voter needs, what all we need about the voter. So if he has voted or not, what is his address, what is his weight, right? And everything, right? So this all we actually need for a voter, right? The information we need for a voter. So basically structures will create basically a place where many variables can be stored, right? Based on what type of values you want. Like if I want the voters value, voters information, then I can create a voter structure with many variables which has the voters information, right? And finally we are gonna move on to enums. So through enum you're gonna create your own data type. Like in many languages you don't have booleans. So what those languages did, they had this boolean, or like I'm gonna say my boolean data type, and they had this true comma false. So now the languages that didn't have true and false created, you could create in those, you could create enumerate types with you could name that boolean, and you could use the boolean types values, right? So basically it's used to create your own data type. For example, if I'm playing a game, I can create my data type state, right? And I can say I want it running, paused, or stopped, right? So this was our enumerate type, and this was the structure of our Solidity contract. I hope you guys liked the video. If you did, don't forget to smash the like button and share this video with as many people as you can. Thank you guys. Bye. Stay safe, stay healthy, and keep watching my videos.